I welcome you all in this lecture of the vector calculus. Now today I am going to start with my unit 4, which is your vector calculus, and in this unit we will discuss the vector differentiation and vector integration. Now in science and engineering we generally deal with the vector quantities such as force and velocity, and these vector quantities varies with the position and time. Now vector calculus is basically extends the concept of differential and integral calculus of real function in an interval to the vector function, and thus enable us to analyze the vector quantities over curve and surfaces in 3 dimensions. Now today I am going to start with the vector differentiation. So suppose that now let us assume that R is a vector which continuously varies as a scalar parameter t varies. So if R is the vector which continuously varies as scalar t varies, then we write vector R as a function of t. So as t varies, your R varies, so we will write the vector R as a function of t, and now the derivative of this R is defined as just like your definition of the derivative, and this is equal to limit delta t tends to 0 f of R f of t plus delta t minus f of t upon delta t. So this is the derivative of this R. Now if P is the position of a particle at time t and q being its position at time t plus delta t, then the rate of change of the displacement is is known as velocity of the particle, and we write dr upon dt equal to, we denote it by lambda delta t tends to 0 f of t plus delta t minus f of t upon delta t. Now the rate of change of this displacement is called your velocity, and the magnitude of velocity and speed of the particle is equal to the modulus of this velocity. So the magnitude of this velocity is your speed of the particle. Now the rate of change of your velocity is known as your acceleration. Acceleration of the particle A is equal to dv upon dt, and is basically equal to d2r upon dt2. Now what is the physical meaning of this dr upon dt? Dr upon dt basically represents a vector in the direction of the tangent at a point P. Note that dr upon dt represents a vector in the direction of tangent at a point P. So this represents the direction of a tangent at some point P. Now say this was your point P with position vector r, and say this is your point Q with position vector r plus delta r, and say this is your chord PQ with position vector delta r. The length will be delta r. So this is point O, and say here is a point A. Now if the arc length of P from A is S, and say this AQ and S plus delta S, now if P is the arc length, if your AP, arc length AP equal to S, PQ equal to S plus delta S, then this is not your PQ, this is your AQ. Then your PQ will be, arc length PQ will be equal to delta S. Now let us evaluate this value dr upon ds. Now your dr upon ds will be equal to limit delta S tends to 0, delta R upon delta S. Now your delta S tends to 0 if your P tends to Q. Now if your P tends to Q, then you can see that your delta R and delta S will coincide to each other. So as P tends to Q, and this was your tangent dr upon dt. Okay, now as we can also write it as limit Q tends to P, delta R upon delta S. Now as Q tends to P, your delta R and delta S will be equal to each other, so this value is 1. So it means this dr upon ds, if we denote this dr upon ds as t, so this implies that t equal to vector t equal to dr upon ds unit vector. So this is your unit vector along the tangent at P. Now this was the value of acceleration of the particle, and this is your speed of the particle. Now the speed and acceleration in a particular direction is given by the speed of a particle in the direction, say B is equal to V into V cap. So this is your particle speed in the direction V, and acceleration in the direction B is equal to A, this is your acceleration, then B cap. So this is the value of acceleration in a given direction. Now let us solve few questions based on velocity and acceleration. So your first question is, find the unit tangent vector at p equal to 2 on the curve x equal to t square plus 2, y equal to 40 minus 5, and z equal to 2t square minus 60. So we have to find out the unit tangent vector at t equal to 2. And this was your dr upon ds. You can say the modulus of this is the unit tangent vector, and your unit tangent vector will be basically dr upon dt upon modulus of dr upon dt. So solution, unit tangent vector is equal to dr upon dt upon modulus of dr upon dt. So this will be your unit tangent vector. So let us evaluate dr upon dt at t equal to t. Your vector r will be xi plus yj plus zk. Here our r is t square plus 2. So we have t square plus 2y, 4t minus 5j, and then 2t square minus 60k. Now if you differentiate this with respect to t, then we will have 2ti plus 4j, and then this is your 4t minus 6 of k. So now dr upon dt at t equal to 2 is equal to 4i plus 4j. Now if you put t equal to 2, then this will be your 8 minus 6, that means 2. Okay. Now its modulus will be, modulus of dr upon dt is equal to 16, square root of 16 plus 16 plus 4. So that means your 36, and that will be your square root of 36 will give you 6. So therefore unit tangent vector is equal to dr upon dt of modulus dr upon dt. So this is equal to 4i plus 4j plus 2k divided by 6. So our answer is 2i plus 2j plus k upon 3. So this is your unit tangent vector on this curve. Now our next question is, to find a particle moves on the curve x equal to 2t square, y equal to t square minus 4t, and z equal to 3t minus 5, where your t is the time. Now you have to evaluate the velocity and acceleration. Find velocity and acceleration at time t equal to 1 second in the direction I minus 3j plus 2k. So here we have to evaluate the velocity and acceleration of the particle at time t equal to 1 second in the direction of this vector. So solution, your vector r is equal to xi plus yj plus zk. So this is equal to 2t square I plus t square minus 4tj plus 3t minus 5k. So this is your r. So now your velocity will be equal to, your dr upon dt is equal to 4ti, then we will have 2t minus 4j plus 3k. Now your dr upon dt at t equal to 1 will be, again further find out double derivative. So your d2 upon dt is equal to 4i, then we will have 2j. Now let us compute dr upon dt and d2 upon dt at t equal to 1. So at t equal to 1, your dr upon dt is equal to 4i. Now if you put t equal to 1, then this will be minus 2j plus 3k. And your d2 upon dt is equal to 4i plus 2j. Okay. So your velocity in the direction, say the vector, the we have to evaluate the velocity and acceleration in this direction. So let us assume this direction as v equal to I minus 3j plus 2k. So say this is your vector v and you say this is your vector a. Now velocity in the direction v is given by v dot v cap. Now our vector v is 4i minus 2j plus 3k into v cap. Now v cap is your I minus 3j plus 2k divided by the square root of, this will be your 9 plus 4, so 13 plus 1, 14. So this is equal to I dot I, which is your 4, j dot j plus this is your 6 plus k dot k, this will be again 6 upon the square root of 14. So this is your 16 upon the square root of 14. Then we can also write it as square 16 into square root 14 upon the square root of 14. So this will be your 8 square root of 14 upon 7. So this is your velocity in the direction of v. Now again, let us calculate acceleration in the direction of v. Your acceleration was, so acceleration in the direction of v is equal to a dot v cap, and your a vector a was I think 4i plus 2j or 3k. Your a was 4i plus 2k. So this was your 4i plus 2k dot v cap. Now your v cap is I minus 3j plus 2k upon the square root of 14. Now this is equal to, now I dot I is 4, then your k dot k is again 4 upon the square root of 14. This was I think 2j. So this will be 4 minus 6 upon this square root of 14. So this is equal to minus 2 upon the square root of 14, and we can write it as minus 2 square root of 14 upon 14. So this is equal to minus square root of 14 upon 7. So this is your acceleration in the direction of the vector v. Now let us define point function. So if to each point PR, where P is the position of the particle with position vector R, so if to each point PR, P with position vector R. So if to each point PR of a region R in a space there exists a scalar function phi of R, if to each point PR of a region R in a space there exists a scalar function phi R, then we call this phi R as a scalar point function of vector R. So then we call this phi as a scalar function, a scalar point function in R. For example, the temperature distribution in a medium is an example of a scalar point function. So the temperature distribution in a medium is an example of your scalar point function. Now, vector point function. Now again, if to each point PR of a region R in a space there exists a vector function f of R, then we call this vector function a vector point function. We call this f as a vector function in R, and your example will be your force or velocity of a fluid, example your electromagnetic force, your velocity of a fluid are example of vector point function. So this vector differential operator, and we call it that. So the vector differential operator is generated by I del upon del x plus j del upon del y plus k del upon del z. So this vector differential operator is defined by I del upon del x plus j del upon del y plus k del upon del z. Now next we define grad of vector, gradient of a scalar point function. So if phi x y z is the scalar point function, then your grad phi is equal to, your gradient of phi is equal to I del by del x plus j del by del y plus k del by del z of this phi, and we can write it as I del phi upon del x plus j del phi upon del y plus k del phi upon del z, and in summation we can write it as I del phi upon del x. Here your grad phi is known as gradient, and we generally write it as grad phi or gradient of phi, and we write it as grad phi or grad of phi. So we write it as like grad phi or gradient phi. Now what is the physical interpretation of this gradient of the scalar point function? So physical interpretation of grad phi. So physical interpretation of grad phi. So let phi x y z be the, say this is your scalar point function, and phi x y z equal to c be the level surface. Level surface means the point which satisfy this equation determine a surface which is known as the level surface. So, and suppose that this phi x y z equal to c is the level surface, then your dr, your vector r is xi plus yj plus zk. So your dr will be dxi plus dyj plus dzk. Then this is your is the tangent to the curve. So this will be your tangent to the curve. Now let us evaluate grad phi dot dr, and let us see what is this grad phi dot dr. So this, now use the definition of grad phi, which is your I del phi upon del x plus j del phi upon del y plus k del phi upon del z. Then our dr is dxi plus dyj plus dzk. As your I dot I is 1, j dot j is 1 and k dot k is 1. So this is equal to grad phi del x dx, grad phi del y dy, and then grad phi upon b del z into dz. Now what is this? This is equal to the total derivative. You have seen the definition of total derivative in my lecture of partial differentiation. So this is your basically d of phi. Now your phi was constant, so your grad phi equal to 0. So you can see that your grad phi dot dr equal to 0. Now this is your tangential vector. Now the product of these two is 0. So that means this grad phi is your normal to the surface. So from here your grad phi is the normal vector to the surface. So basically your gradient phi is your normal vector to a surface phi x y z equal to c, and your unit normal vector to the surface is given by this grad phi upon mod of grad phi. So this is your unit normal vector to the surface. So if phi x y z is the scalar point function and phi x y z equal to c is the level surface, then your dr is the tangent to the, this will be your surface. So then your dr is the tangent to the surface, and del phi dot dr is equal to d phi. Please note that this del phi dot dr will be always equal to d phi. Now as your phi is constant, so this is equal to 0. So it means your grad phi dot dr equal to 0. So we can say that as this is your tangential vector to the surface, so we can say that this grad phi is a normal vector to the surface phi x y z equal to c. Now let us define the directional derivative of a vector of a scalar point function phi. Directional derivative let phi is the scalar point function let phi is the scalar point function, then your directional derivative in a direction b is the rate of change of phi your directional derivative in a direction b is the rate of change of phi in the direction b. Then your rate of change of phi in the direction b is known as your directional derivative. So therefore directional derivative is equal to, so this is your rate of change of phi, so we have grad phi in the direction of b, so we will have b cap. So this is equal to grad phi dot vector b upon modulus of the vector b. So this is known as your directional derivative. Now again we can write it as also grad phi dot b cap can be written as, now your a dot b will be modulus of a into modulus of b. B is unit vector, so its modulus will be 1 into cos theta. Now as your maximum value of cos theta is 1, so we can say that maximum value of the directional derivative is mod grad phi. And again, your direction of the maximum value will be the direction of the grad phi. Whatever the direction of grad phi, that will be the direction of the maximum value of grad phi. So this implies that maximum value of grad phi is equal to modulus of grad phi, and it occurs in the direction of, so it occurs in the direction of grad phi. So whatever the direction of grad phi, that will be the direction of the maximum value of the directional derivative. Now let us solve question based on your gradient and directional derivative. Evaluate grad phi for phi equal to 3x square y minus y cube z square at the point 1, minus 2 and 1. So just evaluate the value of grad phi for this phi at this point 1, minus 2, 1. So solution, your grad phi is equal to I del upon del x plus j del upon del y plus k del upon del z of phi, where your phi is 3x square y minus y cube z square. Now this is equal to I time the partial differentiation of this bracket with respect to x, and the partial differentiation of this bracket with respect to x will give you 6xy, then its differentiation will be 0. Then we will have j time partial differentiation of this bracket. So this is your 3x square minus 3y square z square. Then partial differentiation with respect to z will be equal to minus 3 minus 2 y cube z. And here we have to evaluate this grad phi at 1, minus 2, 1. So grad phi at 1, minus 2, 1 will be equal to, just put the value of x1 and y minus 2. So this will be minus 12y. Then here we will have 3, and this will be your 4, 3 12, so we have minus 6j. And then y is your minus 2, so this will be your 8 to just 16, so we will have plus 16k. So the next question, just evaluate the directional derivative, find directional derivative of 2yz plus z square in the direction I plus 2j plus 2k at the point 1, minus 1, 3. So just evaluate the directional derivative of this function in this direction at this point. Also find its maximum value and direction of occurrence of this maximum value. So solution, here we have to evaluate the directional derivative in the direction of I plus 2j plus 2k at this point, and then we will try to evaluate its maximum value. So let us consider phi equal to 2yz plus z square. So your grad phi will be equal to I del upon del x plus j del upon del y plus k del upon del z of phi, and your phi is 2yz plus z square. Now if you differentiate this bracket with respect to x, then we have 0, Now the differentiation of this bracket with respect to y will give you 2z, and then the differentiation of this bracket with respect to z will be your 2y plus 2z. So this is your grad phi. Okay, so we have the value of grad phi. Now let us evaluate this grad phi at this point 1, minus 1 and 3. So grad phi at 1, minus 1, 3 is equal to, now this will be your 6j, then your y is minus 1, so this will be minus 2 plus 6, so that means 4k. Now your direction is b equal to I plus 2j plus 2k. So therefore directional derivative is equal to grad phi dot b cap. So this is equal to 6j plus 4k dot b cap means I plus 2j plus 2k upon, now this will be 8 plus 1, so we have 3. Now this is equal to 12 plus 8 upon 3, so this is your 20.3. So your directional derivative is equal to 20.3, and your maximum value is equal to modulus of grad phi. So modulus of grad phi will be 36 plus 16. So this is equal to square root of 52. So square root of 52 will be your maximum value of the directional derivative. Now your direction of maximum value is equal to the direction of the grad phi, and your grad phi is equal to 6j plus 4. Now the direction of maximum value is your grad phi, and this is equal to 6j plus 4k. So again note that now let us show that your grad r power n equal to n, r power n minus 2 into vector r, where vector r is xi plus yj plus zk. So solution: as your vector r is xi plus yj plus zk, so please note that your del r upon del x, now the partial differentiation of vector r with respect to x will be I. Similarly, your del r upon del y will be j, and your del r upon del z will be equal to k. Also, your scalar r will be the modulus of this vector, so this will be your r square will be your x square plus y square plus z square. Now from here, if you differentiate this equation partially with respect to x, then we will get 2r, then we will have del r upon del x equal to 2x. So your del r upon del x will be equal to x upon r. Similarly, your del r upon del y will be y upon r, and del r upon del z will be z upon r. And your del r upon del z will be z upon r. Now let us prove this grad r power n equal to n r power n minus 2 into vector r. Now grad r power n equal to, let us use the definition of grad, which is equal to summation I del by del x of r power n. So this is equal to summation I del r power n upon del x. Now this will be equal to I. Now the differentiation of r power n will be n, r power n minus 1 and then the differentiation of r with respect to x will be del r upon del x. Now the value of del r upon del x is x upon r. Now we can take r common, r outside of the summation, so this will be your n. Now this r will go in the numerator, so this will be your n minus 2. Then in the bracket we will have summation ix. Your summation ix is ix plus jy plus kz. So this will be equal to vector r. So your gradient r power n is equal to n r power n minus 2 into the vector r. Now if you put n equal to minus 1, from here your gradient of 1 upon r is equal to, now gradient of 1 upon r means just put the value of n as minus 1. So if you put n equal to minus 1, then we will have 1 minus 1 r power minus 3 into vector r. So this is equal to minus vector r upon r power 3. So this is your gradient of 1 upon r. Now question, evaluate gradient log r. So let us evaluate this gradient of log r. So solution, gradient of log r is equal to, you can write it as summation I del by del x of log r. Your differentiation of log r will be 1 upon r, and then we will have del r upon del x. Now this del r upon del x is your x upon r. So we have 1 upon r, then again we have x upon r. So this 1 upon r square will come outside. In the bracket we have summation ix, and summation ix is vector r. So your gradient log r is equal to vector r upon r square. The angle between surfaces x square plus y square plus z square equal to 4 or 9. Then we have the second surface as x square plus y square minus z equal to 3 at the point 2 minus 1 2. So let us find out the angle between these two surfaces. So solution, let us represent the first surface as phi 1. So we have x square plus y square plus z square minus 9, and phi 2 as x square plus y square minus z minus 3. Then we know that your grad phi is the normal to the surface phi 1. Again, your grad phi 2 will be the normal to the surface phi 2. Then we will find out the angle between two normal vectors. So now grad phi 1 is equal to, grad is I del upon del x plus j del upon del y plus k del upon del z of this bracket. So partial differentiation with respect to x will give you 2xi, then we will have 2yj, and then finally we will have 2zk. So the grad phi 1 at, we have to calculate the angle at 2 minus 1 2. So this is equal to 4i minus 2j plus 4k. Now calculate grad phi 2. Your grad phi 2 is equal to I del upon del x plus j del upon del y plus k del upon del z of phi. Your phi is x square plus y square plus z square minus z minus 3. So this is your phi 2. So this is equal to 2xi plus 2yj. Then we have minus k. Now grad phi 2 at 2 minus 1 2 is equal to, now put the value of x as 2, so we have 4y minus 2j minus k. Now let us assume this grad phi 1 as vector a and this grad phi 2 as vector b. Now angle between A and B is given by your A dot B equal to A modulus of A into modulus of B into cos theta. Now your cos theta will be equal to A dot B. Your A dot B will be 16. Then you will have plus 4. Then again we will have plus minus 4 upon the square root of A will be equal to, so this will be your 16 plus 16, so that means 32 plus 4, 36, so this is equal to square root of 36 into the square root of V will be your 16 plus 4, 20 plus 1, that means the square root 21. Now this is equal to 16 upon 6 square root of 21, so your theta will be equal to cos inverse 8 upon 3 root 21. So this is your angle between these two surfaces. Now show that, now we have the question, show that your surface 5x square minus 2yz minus 9x equal to 0 and 4x square y plus z cube minus 4 equal to 0 are orthogonal at 1, minus 1, 2. So I am not going to solve this question. Here we have to just prove that A dot B equal to 0. So just calculate, say this is your phi 1 and assume this one as phi 2. Then calculate your grad phi 1 and grad phi 2 at this point, and then you have to prove that grad phi 1 dot grad phi 2 is 0. And that can be easily done as we have done in this question. Now our next question is, if ax square minus vyz equal to a plus zx and 4x square y plus z cube equal to 4 are orthogonal at 1, minus 1, 2, then find out the values of A and B. Then find A and B. Just evaluate the value of A and B. It is given that these two are orthogonal at this point. So if these two are orthogonal at this point, then it means their grad phi 1 dot grad phi 2 will be 0. So also, as these two are orthogonal at this point, so as these two surfaces are orthogonal at this point, so this point must satisfy this two equation. So you can see that if you put x equal to 1 here, then you will, and y equal to minus 1, then this will be minus 4, this will be a plus 4, plus 8, so we have 4 equal to 4. And again if you put this point here as 1 minus 1 satisfies 4x square satisfies ax square minus byz equal to a plus zx. So we have just put the value of x as 1, so we have a, then your y is minus 1, so this will be your plus b, your z is 2, so this will be a plus 2b, then equal to a plus z, your z is 2, so we have a plus 2, your x is 1, so we have 1. Now here you can see that your a and a is cancelled out, so our b is equal to 1. So your 2b equal to 2, so we have b equal to 1. So in this case, the value of b is 1. Now let us evaluate a. So for that, assume this function as phi 1 and this one as phi 2. So your phi 1 is equal to ax square. Now you can put b as 1, so we have minus yz minus a plus zx. Your phi 2 equal to 4x square y plus z cube minus 4. Your grad phi 1 will be I del by del x of this one. So your del by del x will be 2ax minus a plus z plus j times your del by del y of this bracket will be your minus z. Then k times del by del z of this bracket So this will be minus y. If you differentiate this bracket with respect to z, then this will be your minus y, and differentiation of z will be minus x. So this is your grad phi 1. Now let us calculate this grad phi 1. Say this is your vector A, or you can write it as vector, say, P. So your vector P is equal to grad phi 1 at the point 1 minus 1 2 is equal to, just put the value of x as 1. So we have 2a minus a, so this will be your a minus z, and your z is 2. So this will be your I times a minus 2. Then we will have minus 2j. Your y is minus 1, so we have this vector as plus 1 minus 1, so this is your 0. So this is your p. Now grad phi 2 will be equal to I del by del x of this bracket, so this will be your 8xy. Then you will have j del by del y, so this will be 4x square, and k del by del z, so this will be 3z square. Now say this vector is q at the point 1 minus 1 2. So if you put the value of x as 1, y as minus 1, then this will be minus 8i. Then we have this vector as 4j. Then put the value of z as 2, so this will be 4 is 12, so we have 12k. Now it is given that p and q are orthogonal, so as p and q are orthogonal, so this implies that p dot q equal to 0. So that means p dot q means your I dot I is 1, so we have minus 8 into a minus 2, then we will have j dot j, so we have minus 8 equal to 0. So from here we will get a minus 2 plus 1 equal to 0, so we have a equal to 1.